All right, very quickly, I'm going to do a Gretl, the Gretl how-to that we did in class. So that's going to require sharing my screen. And so here we are, screen sharing and Gretl. So we open our Gretl, and I know some of the Mac people had issues, but it was only on Monterey. And I sent out hopefully the right stuff to do that. But here we are. So we are going to go to open data, and we would do user file and Pelkey and downloads. And I got to change that down here to Excel SX. You notice one of the cool things about Gretl is it reads in almost every format, which is nice. There's table A4. Open it up. I'm going to use the first tab because that's the one with the data that we want. And there we go. So we were testing the Andrew Heaton's theories that, or proclamations that capitalism made everybody better off. And, you know, the poor probably have the most to say about that. So the first one we're going to do is view a time series plot of the income of the bottom 10, and we'll say, okay. And it looks like, well, that goes up pretty much over the 50-year time period from 1967 to 2022. We've got a nice general upward. It goes up, and then it flattens out. It goes up, and then it comes down. It goes up. So the poor kind of on a income roller coaster, right? So hard to build up those resources when you're in income ups and downs. But so let's but in general, he was right. It's up. Do the rich get richer? We'll do the 95th. And okay. And sure enough, as was pushed, the rich, they certainly get richer. They only have little tiny downs, not the big ones that the poorest group have. And they had a pretty bad flat spot in the Great Recession where incomes were flat for about 15 years. And so this is year, and this is the total dollars. So you can see that this top 95th was roughly an order of magnitude higher than the bottom. One of the things that we like to do as economists is look at time series. And to do that, we are going to add, we could do lags, we could do lag differences, but we're just going to do a percentage change so we can look at these on the same basis. So we're going to create a percentage change of 10, 50, and 95. I use the control to select those. And then I add the percentage change of the selected variables, and I'm not going to do log changes. So here we go. We have the percentage change of the 10th, the 50th, and the 95th. This is the percentage change. It gives you the formula here. One times the item over its log minus 1. And so here we go. That's our percentage change formula in Gretl. And now we can go ahead and view in our time series plot. We'll go down and we might have to do an XY scatter and use key, and then go down and grab these as our time series didn't want to plot those differences. Oh, and we don't have it. So there we go. Time versus the 10th, the 50th, and the 95th. And we're going to say, okay. There we go. It was just being a little bit pokey there in the time series. I tried the XY, that just gave us a dot plot. That wasn't what we really want. But what we noticed very quickly is that both the middle and the two ends, they move up and down. Everybody's sort of, the boats go up, the boats come down, the boats go up, the boats come down. And what we end up seeing here, this is just a little bit problematic, is that everybody's kind of moving together. And that's kind of cool, moving up and down together, but we still go back to those graphs where we add that, we view that time series graph, and we look at the 10th, the 50th, and the 95th, and okay, and lo and behold, honest to goodness, we see the lowest, the 10th, they look very, very flat, even though we know they go up relative to the 95th percentile. They go from being, from 14 to 140, which is 10 times, to 280 to 18. So that relative difference has gone way, way, way up. Now, maybe the rich are oppressing the poor, or maybe it's just that growth rates on bigger, larger sums of money end up with the amounts being much larger. And we're going to do that in Gretl. We would normally do this in Excel, but we'll go to Tools and the Gretl console. And here we will do equal to times 1.035, which is the long run growth rate, to the 10, and times 15000, which is our starting. And we see that we end up with, oh, I have 2 times that. We just need the one times that. Hit the up arrow a couple times to get that. And now we hit it and we see that we've got 21,000. That's a pretty good increase. That's, a $6,000 increase. We're going to hit that up, and we are going to go to that 200,000 that our initial group should be 280, but we'll do that. And we see that there, but 200 makes the math easier. We see that this group has gotten better off by $6,000, and this group has gotten better off by $80,000. So this group has gotten better off by far more than this group. The increase for this group is bigger than what this group makes. So we do actually see that, and all it is a compounding growth of an initial rate. And so if everybody is moving up and down at the same rates, then we would need to equalize the differences. And for equity, we would not only have to give equal returns to the poor, we would have to give them, sort of supernatural returns to get them to get the poor up to those levels. And we have, as a society, been unwilling or unable to do that, to have the growth rates for the poor be much faster than the growth rates for the wealthy. Typically, honestly, it's usually the other way around, where the rich can invest their money at higher interest rates. The poor have access to savings accounts at 1.5%, and the rich have access to equities, which often grow at 13%. So we see that difference explode, but it doesn't need to be there. We just need an exponential growth in people's wealth or income levels and a different starting point. Now, there may be heinous stuff, but my experience is in life that the rich have, that I know, at least try to help out the poor, but the problem of simply that our society and our economies aren't built to take the people at the bottom and give them higher returns on their investment and their incomes than you would expect. So if everybody moves up and down together, which is what we saw, the rich are going to get richer. We're going to see that gulf because resources tend to grow, at least sometimes exponentially, and we will look at when they don't, but trees grow really fast for a while, and then they're worth less. But values tend to grow exponentially when you put things in the bank. Interest compounds. Compounding leads to this ever-growing difference without any ill intent at all. And so maybe we need to find ways to get higher value, higher compounding investments to the poor, maybe government matching, maybe stop charging high interest rates on loans to the poor, yada, yada, yada. It's a lot of ways to look at this, but mostly I wanted you to see that if you take a resource and you have two different kinds of labor resources, the more valuable one in a compounding situation is going to end up being even more valuable over time. And if you wanted to change these to 20s, you see 379. And 29. So now we have this one's gone up 200,000, and this one's gone up 14. So the poor family's got $14,000 more per year, and the rich family has, well, 198,000 more a year to do stuff with. And as I said in class, it means this group, even growing at normal rates, the 200,000 growing to 400,000 over a 20-year period is why we have a fractioning society by income and class levels. And that's it, but that's using Gretl. It's quite powerful. It has some very, very nice multivariate time series models, which we will look at when we get later in the course. No, it's not a stat course, but when we come upon an economic question, we're going to try to look at it. We'll do some Excel stuff because Excel pet tricks are cool, but we will look at this in the way that an economist would. Gretl, they say, written by economists for economists. All right, there's some reasonably good user guides. And since I'm stumping for it right now, we'll go to scholar.google.com. And we will look for Gretl. Okay, we see marine geology. Oh, it's super accurate. State-based methods. Well, they seem to have published more stuff about Gretl than stuff being published with Gretl. As I said, mostly it just shows you that you can do an awful lot of stuff with Gretl. And it's not used a whole lot in research because, well, it's just not. Something like eViews. Again, you'll see it. Used, but again, most software comes up. You will see it used a little more. If we came over here and we did forest economics and eViews. All right, so now you'll start to see that eViews is used. If you go down and you look, that people have used eViews in that aspect, and we will also look at, which is a software package. We'll look at Gretl and see if it's used in forest economics. And as you can see, Gretl's basically used for teaching. So again, it plugs into the more powerful software packages. But again, it is what we're going to use. It does everything we need to. It's not expensive, and other than the little glitches to get it to run on Macs, it's pretty bulletproof.